In this video, we're going to take a look at random variables, probability distributions, and expected value. A probability model is just a way to show all of the possible outcomes and the corresponding probabilities. So let's say I tossed a coin 3 times and I wanted to see how often I would get a heads. The first thing I'd like to do is I'd list out the sample space. So I could get 0 heads by getting tails, tails, tails. I could get 1 heads in 3 different ways, depending on whether the heads was first, in the middle, or last. I could get 2 heads, again in 3 different ways, or I could get 3 heads. Now, if I turn that into a table, I count up that there are 8 possible outcomes, and I count up how many of them correspond to 0, 1, 2, or 3 heads. That table is the probability model. If I then take that and turn it into a histogram, I get this distribution, and you can see how this relates, where here I have the chance of getting 0 heads is 1 out of 8, and then that corresponds to this bar for 0 heads, and it goes up to 1/8. Now the random variable, that is the x. So in this case, the x is the number of heads that I get when I flip the coin 3 times. And the probability distribution again is the graph, and the probability model again is the table. There are 2 types of random variables, discrete and continuous. Right now we're looking at discrete random variables, which basically just means that we could list all of the possible incomes. We could get 0, 1, 2, or 3 heads when we flipped a coin 3 times. Continuous means that we can't list them all because there's an infinite value of numbers in between. That would happen maybe if I wanted to look at weights and I could weigh 150 pounds or 150.1 pounds or 150.01 pounds. And it would be impossible to list all of the possible weights because there are so many. We'll get to continuous random variables a little bit later, but for now we're working on discrete random variables. A couple of things to keep in mind is that all of the individual probabilities, which are these values in the second row of your table, they all individually have to be somewhere between 0 and 1. And when you add them all up, they all have to add up to 1. Now, earlier in the year, we studied distributions, and we described them with 4 sentences: shape, center, variability, and outliers. We're going to do that same thing with random variables, both discrete and continuous. And for the center piece, we're talking about mean, but we're also going to start using the word expected value, which is just another word for mean. So to calculate the expected value, what I have to do with my table, my probability model, is I have to take each of those individual outcomes and multiply it by its corresponding probability and then add those all up. So here's what the formula looks like. Here's each of my individual outcomes times their probability, and then I take all of those and I add them up. So that's what this summation symbol means. It means I'm taking all of those values and finding their sum. So let's do an example. A baby's APGAR score is the sum of the ratings of each of 5 scales, which gives a whole number value from 0 to 10. Let x equal the APGAR score of a randomly selected newborn. So here we have a distribution, and we can see the numbers from 0 to 10 and their probabilities. We want to find the mean or the expected value. So what we're going to do is we're going to take each individual outcome, multiply by its corresponding probability, and then add those up. So here's your 0 times 0.001 rather. Here's your 1 times 0.006, and so on until you get to the end. And when you add those up, we get 8.128. So that is our expected value, or our mean. So on average, we would expect a randomly chosen newborn to have an APGAR score of about 8.128.